Yep.
So again, welcome everybody to this talk on space. And I'm going to start out with a presentation and it'll probably last for roughly a half an hour. We'll see how that goes. And then I'm really going to be happy to talk with you and answer any questions that you might have. So I'm going to go ahead and start sharing my screen. Okay. All right. So we're going to be talking about exploring the Earth and the universe from space. So again, my name's Mark and I'm an aerospace engineer. So what does that mean? It means that I design spacecraft. I figure out how they are going to work, what parts they have, and how that's going to fit together. And then once we're done with the design, I help to actually put them together, test them, and launch them into space. So I've been working on spacecraft basically my whole career, and I've worked on many different spacecraft. I'll answer one question right now, which is I'm not an astronaut, but I get to work with a lot of really cool people, and I have worked with several astronauts. But anyway, I and my NASA colleagues, we work on the ground to figure out how to launch spacecraft, both with people in them, and most of the ones that I've worked on are what we call robotic, that don't have people in them. So let's start out just a little bit more about me. So how I got interested in space in the first place. When I was growing up, there was a lot of things happening in space, particularly people flying to the moon, which was very excited. So here's some pictures of me and my sister flying model rockets, which was really fun. And actually, I learned a lot from doing that. This is in Philadelphia. And then a few of my inspirations. When I was starting out in college, I wasn't sure what I wanted to do. But at that time, the first space shuttle was launching. That was Shuttle Columbia back in 1981. And at the same time, not only was the shuttle launching, but they were talking about all these really interesting and cool things that were going to get launched into space, particularly the Hubble, or the Space Telescope at that time. It didn't have a name. So these were a couple of the things that really got me interested in wanting to become an aerospace engineer. So what is a spacecraft? Why are we interested in it? So spacecraft are basically a special kind of tool that serve people in different ways. One way is understanding the Earth, and I've worked a lot on spacecraft that look down at the Earth so we can understand it and know how to take care of it. Providing information that people can use, for example, GPS satellites that help us figure out where we're going to go. And then just from a more really fun and fascinating standpoint, exploring the universe. So we're going to start out by looking at Earth with a couple satellites that I've worked on. But first, I want to show you this picture. So this picture was taken back in 1968 by the first manned spacecraft, Apollo 8, that went around the moon. So it was funny because in the earlier part of the mission, the astronauts couldn't actually see the moon. And when they came around the moon for the first time and they looked back at the Earth, they saw this beautiful picture. And this picture got sent around the world and really got people interested in taking care of the Earth, environmental causes and things like that. And it led to the first Earth Day. And we just had the 50th Earth Day this year in April. So a very, very important image, shows you how one picture can really inspire people. So here's a satellite called TERRA that I spent almost 10 years working on. It was actually built right here in our area in Valley Forge. And it's a very large satellite. You can see by this technician down at the bottom. He's not holding the spacecraft up. It's held up by a crane, but it's basically the size of a school bus, so it's very big. And it's got a whole lot of cameras and sensors that look down at the Earth and get information from it. So TERRA was actually launched over 20 years ago. So that's a very long time. That's like a 100-year-old person for a spacecraft. And it's still working really, really well. And that's because we had a great team of people that worked on designing it and building it. So here's a picture of what you have to do when you get ready to work on a spacecraft. So we're all kind of wearing masks to protect ourselves these days. But when you're working on a spacecraft, you have to protect both yourself and the spacecraft. You have to keep it very clean, keep it from getting contaminated. So you can see I have a full suit, a mask, gloves, all that stuff. We are very, very careful when we're working around the spacecraft. Here's a picture of us putting the satellite together. You can see it's got this frame that's kind of like a skeleton. And then it's got a whole bunch of stuff that we attach to it. The cameras that are kind of on top of it in this picture, wires all over the place, connecting everything, electronics, and a bunch of other stuff. So there's a whole team of technicians, people that do the work to put it together. And then engineers like me work together with them to make sure that everything is put together properly. Here's a picture of when we were done. Once we had the spacecraft built, we took it down to California, where it was to be launched, put it in the nose cone of the rocket. You can see the two halves of the nose cone here. They come together. Basically, they both move together to cover the spacecraft, to protect it while it's being launched. And then that whole thing is lifted up into a crane inside this building here. And the rocket is actually inside that building. So when we get ready to launch, we open one side of the building and you can see the rockets in here. So this is a really big rocket, and the satellites in this nose cone that we just saw. This entire building, it's like an 18-story building, rolls away so that the rocket is free. And then after working on it for 10 years or so, here's me on the launch pad, actually the night before launch. This thing in the background is the very tippy top of the rocket. And then here on the right, you can see the launch. I was working in the control center, and we ran outside and we watched the launch 6 miles away, and then we ran back in and got back on our computers. But it was just really, really very exciting day. All right, so once the spacecraft's in orbit, the way this one works is it actually goes around over the North and South Pole, and it takes information, and every couple of days, it can see the entire surface of the Earth. All that information is put into a computer, and then it can make pictures and create information that can be used in all different ways. And this is a climate research satellite, so it's really trying to understand our planet and climate, both what it is when the spacecraft's looking at it, and then how it's evolving over time. And since this has been on orbit for 20 years, there's a lot of information that it's gathered. This is one of my favorite pictures showing the Earth, put together with data from TERRA. I've got it on my phone. If you keep your eyes out, you'll see this picture all over the place. One of my favorite pictures. And then here's some examples of different kinds of information from TERRA. You can see we can measure the temperature of the Earth. The green on the upper right is the vegetation varying over the summer and the winter, going back and forth as our country gets cold and warm with summer and winter. You can see smog in the lower left, which is obviously bad. We can use it to measure pollution. And then on the lower right, we can see a map of fire. You see all those red and yellow dots, those are all fires that are either natural or man-made. And you can see there's a lot of fires that are occurring on the Earth at any particular time. Now I want to tell you about a newer satellite that I've been working on more recently. It's called the GOES-R weather satellite. It's very important for weather forecasting and for storm warnings. And we've had some pretty bad storms recently, and the information from this spacecraft is part of how we get warnings and can protect ourselves from storms. The older spacecraft, the older weather satellites like this are pretty old. And basically going from the older ones to this new GOES spacecraft, if there's anybody that remembers black and white TVs like me when I was a kid, it's like the difference between a small black and white TV and a color HD big flat screen TV. In other words, a really, really big improvement in pictures and how often we get the information. So we're getting really great data from it, and it's helping us understand weather and have better weather forecasts. So here's a picture of us in the clean room. So this is a special room like the other when I was showing you assembling Terra. All these rooms are basically climate controlled. We keep the dust down, we keep everything very clean, and we're all wearing these white suits to protect ourselves and the spacecraft, as I mentioned. So the two main instruments that look at the Earth are on top of the spacecraft, and I'm responsible for the part of the spacecraft that these instruments get attached to. So very, very important part of the spacecraft. So on the left, you can see us lifting. This is the main camera, the most important instrument. And by the way, this camera costs about $1 billion. So we have to be very, very careful when we're handling it and moving it around. And then on the right, we're showing that camera being carefully put down and attached onto the top of the spacecraft. You don't see me in here, I'm over on the other side, but you can see a bunch of my friends and colleagues that are working to put this together. We're actually going to be doing this again on another satellite in just a couple weeks. So this is a picture of me, and this is right before we sent the spacecraft to where it was going to be launched. We're constantly inspecting and making sure that the satellite is built correctly and everything is good. Once you launch a satellite like this, you can't fix it. You can't get to it. So we have to be very, very careful and diligent, making sure everything is right. So really exciting. So we now have two of these new weather satellites called GOES-R and GOES-S. The R is over the East Coast, so it's what we get our data from. So if you are looking at the TV news and they show a weather forecast, they'll be showing pictures from GOES-R. And then there's another one over the West Coast. All right, here's a picture of the Earth from GOES-R. Beautiful picture, of course. And then here's a really, I hope you like this animation. This is from an instrument that detects lightning. So look at the yellow flashes and the clouds. So that's a very, very intense storm that's sweeping across, and the lightning is right at the edge of the storm. So that's where the storm is the most severe. This is a new instrument, and it's helping the people making the weather forecasts get really important information. So that's a new thing here. This satellite also looks at the sun. So the sun is very active. It's got storms on it, just like the Earth does. And they move around and they affect actually our weather and communications and spacecraft too. So we need to understand not just what's going on the Earth, but also on the sun. So some of the benefits of this weather satellite, I've mentioned weather forecast, storm warnings, basically to give people longer time to take cover if there's a storm coming. Also giving astronauts and satellites warnings if there's a storm on the sun. And it also can help rescue people that are in distress with a special beacon. So there's a lot of really useful things about this new weather satellite. So now I want to talk to you, shift gears a little bit, talk about learning to live in space with the astronauts. So there's a space station called the International Space Station. There's usually 6 crew on it all the time, and it's a lab that we can basically study how space affects people and activities that we can do in space. The astronauts that go up on it are women and men from many different countries. And one of the big things that's going on now is practicing for what people need to do to live in space for a long time, to go on a mission away from the Earth. What does space do to their bodies? And how can we work effectively in space. Here's a picture of the space station. It's a beautiful picture. It was built over a number of years by the space shuttle. And these are some fun pictures of the astronauts in the space station. Obviously, there's no gravity in space, so you can just float around and be moving around all over the place. So I really like this picture showing all different people here. There are a number of experiments that they're working on all the time. Some of the things that they're looking at on the space station are medicines and chemicals that can't be made on Earth. So that's a really important thing that's being studied on the space station. Every so often you have to go out and fix something on the outside. So you do a spacewalk, either to repair something or to put new equipment in. Be fantastic to be the one doing the spacewalk. And you have to exercise because there's no gravity. You have to keep your body fit, so you're constantly exercising. And this person actually ran a marathon in space. Plants and growing plants is a big thing that we're studying because we want to be able to have food in space that can be sustainable. So they're doing a lot of studying of different plant growth. Also using different kinds of robots. The one on the left kind of looks as like a person, that's Robonaut. And then on the right, you see this thing that looks like a box. That basically is another kind of robot. And both of these are to assist the astronauts in doing the work that they have to do. This is probably the most fun place on the space station. It's an observation deck with windows that you can look out, either to take pictures, and you see a lot of pictures taken from the space station, and also to just have a nice place to look down at the beautiful Earth. So that's something that would be really exciting to do. Be up there and look down at the Earth and look into space through those windows. Last year, something really exciting happened, which was the first all-female spacewalk. They always go out in pairs and two astronauts so they can help each other in different ways and if they have a problem. So Christina and Jessica went out and they were working on part of the power system for the space station. They did a great job, just like all the astronauts do. And you can see them after their spacewalk on the right, very happy to have accomplished their work. So recently, you might have seen a recent launch that's a new way to get astronauts to the space station, which is a Falcon 9 and a capsule called the Crew Dragon. That's this capsule over here on the left-hand side. That's where the astronauts are. And then that's on top of this big rocket. The rocket has two stages. The first stage, which actually goes for a while, and then it comes back and lands. And then the second stage, which gets it the rest of the way on the orbit. And then on the left, there's this tower that pulls away as the rocket gets ready to lift off. So we'll see a video in a minute to show that. So getting ready for the launch, the astronauts actually had to be in quarantine for 2 weeks to make sure they didn't have any sickness or anything that they would bring up to the space station. So before they went into their rocket, they had some air hugs with their family members, and then they got suited up. And here they are, ready to launch in their capsule with the rocket on the launch pad. Launch pad shown over here on the right hand. And this launch pad has been around for a while. It's been used for missions to the moon and for the space shuttle. So now I'm going to show you a highlights video that I put together for this launch. Let's take a look. So that white smoke coming out the top is liquid oxygen. That's normal.
T-minus 15 seconds.
When you see that, it means the rocket's ready to launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Spot and Doug.
America has launched. So rises a new era of American spaceflight, and with it the ambitions of a new generation continuing the dream. 20 seconds into flight, stage 1 propulsion is nominal.
And when they say nominal, that means everything's working just fine.
3 plus 30 seconds into this historic mission. Flying crew on board Dragon and Falcon 9, and look at them go.
Falcon power telemetry nominal.
And this first stage burns for
1D
about 2
throwdown.
minutes.
We're throttling down to get ready for the period of maximum dynamic pressure.
That's the part of the
We're
mission
in the throttle bucket.
that's the most stressful for the rocket.
Reports say all systems are go.
So now we're going to skip ahead to when the
We're
first stage
throttling down the
burns
Merlin
out.
engines
It's
on the first
throttling
stage.
down, and the picture on the left is actually inside the rocket, and you're going to see the first stage separate and fall away, and you'll be
we
looking
have
at the
Miko.
second stage.
Falcon stage separation.
And there it goes. So the first stage separates, and you see the second stage engine
Impact ignition.
is firing. And the picture on the right is actually of the second stage engine. You'll see that get red
We have
because
stage separation confirmed. The first stage beginning its flight back. The second stage being powered by that single Merlin 1D vacuum engine has ignited and is now carrying Bob and Doug into orbit.
you can see how hot that's
Now we
getting.
are waiting for our first stage to make its way to our drone ship. Of course, I still love you.
Dragon SpaceX nominal orbital insertion.
So this ship is out in the middle of the ocean.
Nominal orbital insertion.
And what you're seeing on your screen is a live view of our drone ship, where our first stage will be coming down.
Sometimes they lose the signal. That's
Looks
okay.
like we lost that live view, but we'll wait for confirmation of that landing shortly here.
And there it is.
And there you can see on your screen, Falcon 9 has landed. This is the first Falcon 9 to carry humans to orbit, so very exciting for us.
Standing by for separation.
Now here's where the capsule separates from the second stage.
It sounds like we had an expected LOS
And
loss.
there's the mission control. The controller's working on watching the mission, and there it is.
Now of that
Dragon separation confirmed.
Dragon separation confirmed.
There is a great view right in front of you of
Countdown 1 to
Dragon separating.
Confirmed.
And there's that call out. Dragon is now officially making its way to the International Space Station today.
Really, really exciting view.
Dragon SpaceX with that separation call. We have a few words for you from our Falcon 9 team.
Okay, and here's
We're
the
inside
capsule
hands-off
docking with the
point,
space
chopper from
station.
Hands-off point, 1 meter to go.
All automatic. Nobody is doing it. It's just the computer flying the spacecraft. And you'll see it contact and then damp itself out. There it goes.
Soft capture complete.
And now it's docked with the space station. And then finally, here's the astronauts coming out into the space station.
We have Bob Behnken from SpaceX Demo 2 mission entering the International Space Station.
And of course, they're very happy to be there.
Followed by Doug Hurley.
All right. So very successful mission so far. So those astronauts are all still up on the space station, and they're going to be there for a couple more months. So I hope you enjoyed that. And we're going to fast forward through these pictures because we saw the movie. This was kind of fun. You know, you can see the astronauts in their seats during the mission. They're strapped in. But then once they're in orbit, they can float around. And this astronaut, Bob, decided to bring his son's toy dinosaur to float around and have fun with. So I just thought that was a fun picture. All right. And then meanwhile, the first stage landed. We mentioned that, and it came back on a barge. You can see on the picture on the right, it's kind of burned and scorched from coming back through re-entry. But they'll be able to reuse that, fly that again on another mission. Okay. And we saw that. Mission control with all the mission controllers now seeing that all the astronauts safely on the space station. And there's actually 5 spacecraft now that are docked with the space station. The Crew Dragon, And then there's several spacecraft that have brought cargo up, this one, and this one. And then the Soyuz, which brought the other astronauts up. So it's a busy time up on the space station. And I really like this. So one of the commentators for the launch, maybe you saw him, was a former astronaut, Leland Melvin, who flew on the space shuttle. And he basically was saying, you know, this is a demonstration of what we can do as Americans when we all work together. So I think that's a very important message. And working together as a team, you have to have a great team working together and cooperating to make a complicated mission like this work. So what's next? Okay, next thing is we're going back to the moon. So last time we were in the moon was 1972, and we're trying to get back there in the next few years. Here's a picture of a spaceship that we're envisioning to be able to take us there with a capsule that some friends of mine are working on, the Orion capsule. And when we go back to the moon, the idea is to be able to stay there for a much longer time than we've gone before. They're going to be sending robot landers to go first to check out landing sites and also bring supplies. And then they'll come down with a lander like you see on the right-hand side. And there's a couple different companies that are working on the landers. So it may not look exactly like this, but a lot of people are using some good imagination and good thought onto what these landers would look like. So this is going to be happening in the next 5 years or so. So keep your eyes out. It's going to be really, really super exciting when they get back to the moon. So let's go away from the Earth and look at Mars a little bit, because a lot of people are interested in Mars. So we've been exploring Mars for a while, because before we send people there, we need to understand it. What's its atmosphere and its climate, and how could people survive and work there? We've been exploring it with robotic spacecraft for a long time, and each mission gives us some new information. Just an idea of the size of Mars relative to the Earth and the Moon. And we can only go there basically about every 26 months, just because of the orbits of the Earth and Mars. So we can't just go anytime that we feel like it. We have to plan that out very carefully. Here's a satellite or a spacecraft that I worked on that takes pictures of Mars, very high resolution pictures, and they use this information to figure out where they want to land. So one of the rovers you've probably heard of that's there now, the latest rover, is called Curiosity. That's got a number of different tools to study the rocks and the geology of Mars. And the newest one actually is not a rover. It stays in the same place, but it's looking at the soil. We need to understand what the soil is like before we could try to live there. And they're looking at that in a couple different ways. They have this sensor that actually is looking for if there's Mars quakes, shaking of the ground, and they have detected Mars quakes, as you can see in this little plot over here. And there's also a device that's drilling down deep to understand what the soil is made out of. So here's our daily weather report from Mars. So Mars is cold, especially at night. So the low temperature, minus 138 degrees Fahrenheit. So the coldest we ever get is maybe -5, -10. So obviously people cannot live there because of the temperature and because of the lack of atmosphere without a spacesuits or something to protect them. So this summer, very exciting, there's another spacecraft going to Mars, and it's called Perseverance, a really great name, and a 7th grader came up with it. And perseverance, if you don't know that word, means steady persistence in a course of action, especially in spite of difficulties, which I think is very important here. And they're going to make this work, and we're going to get some really good information from this spacecraft. So this is kind of an advanced version of Curiosity that's got new tools and sensors to study Mars and understand more about it. And one really cool thing is it's going to carry a little helicopter. And a friend of mine has actually been working on this. The helicopter is folded up inside the rover, and it will detach, and then it'll fly around and be able to take pictures and send them back to the rover and back to Earth. So it'll be able to cover a much larger area than just the rover can driving around. So this is really, really exciting. You can see the folks over here on the left, they're inspecting it before they were getting ready to launch. Right now it's down in Florida, and it's going to be hopefully launching in July. So when people eventually go to Mars, here's an idea for what a base might look like. They're usually, the ideas for these things are different pieces or modules that are put together, kind of like the space station. And here's some pictures of a vehicle. This was an experimental vehicle that they drove around in the desert to practice what it would be like using a vehicle like this on Mars and getting out, in and out of their spacesuits. All right, so now we're going to go to our last main topic, which is exploring the universe with space telescopes. So now we're going beyond Mars and looking out into our solar system and into the universe. So one of the big space telescopes that you may have heard of is called the Hubble Space Telescope. So here's the telescope that I told you was one of my inspirations back when I was in school. And it was launched 30 years ago this year. So that's really, really old for a spacecraft on the space shuttle. And it was designed so that the space shuttle could go up and repair it and even make it better, put new instruments and new parts in it so that it could last a long, long time. And that's why it's been able to last 30 years, and it's going to keep working for a bunch of more years. So I was able to work on the last servicing mission where they went up and worked on the space telescope. I worked on this part, which allowed them to bring up a very new camera. And here on the right, they're replacing that camera, which is much more powerful than the one that was in there before. And now I'm going to show you some pictures that that camera took. So here's some beautiful pictures. A lot of them are of what are called nebula. It's basically a cloud of gas in space that's been basically comes out of an exploding star. And they can be all different colors and all different shapes. Here's a really cool one called the Butterfly Nebula, and you can see it looks like a butterfly. There was a star in the middle there, and that star exploded and shot the gas out on both sides, and that's how you got this really special shape. Here's a picture, not of a nebula, but a whole cloud of stars. And I like this because it shows all the different colors of stars. Stars have all different sizes and colors and temperatures. So the blue ones are actually the hottest ones, not what you might think. The red ones are the coolest ones, and the yellow white ones, like our sun, are kind of in the middle. And this is a really beautiful image that they just took for the 30th anniversary, and it actually has two nebula. One that's kind of shaped like a bowl, and this other one was shaped like a ring. Originally, there was a star in the middle of that ring. It exploded and shot this ring of gas out. So, you know, these pictures are really interesting for the scientists, but they're also just really beautiful to look at. So I hope you've seen some of these, and there's some great, if you look on the internet, there's all kinds of wonderful pictures from the Hubble Space Telescope. So I'm working on a new space telescope that's going to go up in a number of years. It's kind of like a successor to the Hubble Space Telescope. And it's named for an astronomer. Her name was Nancy Grace Roman. So she was actually NASA's first chief astronomer. This is a picture of her back in the 60s with an old computer, but she was a very, very, very smart and talented woman. And she had a lot to do with telescopes like the Hubble Space Telescope getting built in the first place. So really exciting. So what's this telescope going to do? It will be able to see 100 times as much stars at a time as Hubble. So we'll be able to get way, way, way more information and help understand some of the things that are kind of astronomers are trying to figure out that don't make sense to the astronomers right now. So getting all that information 100 times more quickly will really be very, very important to the astronomers. So I'm really excited to work on this mission, and it'll probably launch in another 4 or 5 years. And just ending up, I hope you've seen this picture, but whether you have or not, this is a fantastic picture of a black hole. So a black hole, as you may know, is a star that is collapsed, and it is so massive, its gravity is so strong that nothing can escape it if it gets too close. Even light gets drawn into it. So the center of it, you can see, is dark. This middle part here, that's where the black hole is. And then around the black hole, this is gas and other material that is getting sucked into the black hole. And as it gets sucked in, it gets hot, and that's why it has these colors on it. So making a picture of a black hole is very, very difficult, very hard. They've been working on it for years. And it took a huge team of people around the world taking pictures from, or information from, a whole lot of different telescopes and putting it together to make that image. So this is a really great example of cooperation, not just people within the United States, but different countries using different instruments, but putting all that together to achieve a common goal, which is making this fantastic picture. So very, very inspiring story. Meanwhile, there's another team of people that are working from home like I am. These are the people that are working on the Perseverance rover that we talked about before. They're making sure everything is ready, and as they get ready for launch, they're doing all the work that they need to do to get ready so we can launch in July. So they're hanging in there just like everybody else, and they're doing their work and keeping things going. And it's really important. I always like to say when I'm talking to groups like this that, you know, different types of people working together really make a great team. When we're trying to solve complicated problems, we need a lot of different ideas and a lot of different perspectives. So when you have different folks from different backgrounds working together, you're going to come up with a much better solution and a successful mission. And this is my last picture. This is our team that was working on TERRA that I showed you before. This is just a small part of our team, but basically when we were almost getting ready to launch, we got everybody together for a picture. And I am all the way over here. But again, it's a big team effort to work on a project like this. And I'm so, so lucky because I work with fantastic, smart, and really good people in my job. Okay, so that's the end of my presentation. So now I would like to go ahead and see if I can answer some questions. So I'm going to stop sharing for now, and we can see who's got some questions. So you can use the chat window if you want to write down some questions, and Liz, maybe you can help me identify some of them. And I see one that I always get asked, so I'll go ahead and answer it. There's a young man named Max who'd like to know what happens to things that get pulled into the black hole. Well, Max, we really don't know that. That's a very good question. A lot of people are trying to figure that out. We just got this first picture of a black hole. It's probably going to be a long time before we figure it out because there's so much intense gravity. Anything that gets pulled in a black hole would probably get pretty squished. So if you got pulled into one, you probably wouldn't do too well, but that's something that we're trying to figure out. And you know, that's another cool thing about space. We've learned a lot in 50 years or so of working on space, but there's a lot of cool stuff that we're still trying to figure out. So very good question, and thank you for asking that. So let me go on from the chat and see what other things we have. Yeah, I can. So, so Charles Don, do helicopters fly different in space? Well, yes. So on Mars, the atmosphere is very thin. I didn't want to take too much time to talk about that, but the atmosphere is very thin. So the blades on the helicopter actually have to spin really, really fast so that it can take off. It's a lot harder for a helicopter to fly in Mars because the atmosphere is so thin. But I told you my friend worked on it. They actually did a test where they put the helicopter into a special room and sucked most of the air out so that the air that was left was basically about the same amount of air that's on Mars. And they flew it around and it worked really well. So yes, they do fly differently, but they've tested it and hopefully it'll work when it gets to Mars. Elijah had a question. What is all the gold stuff on the Terra? Excellent question. So space is very, very, it's a harsh, kind of mean environment. So with a spacecraft like Terra that's going around the Earth, sometimes the sun is hitting it and it's really hot. And then sometimes it's behind the Earth and it's very cold. So what do you do if you are out someplace and you're worried about getting cold? You have a blanket with you or something like a blanket. So the gold stuff is actually special types of blankets that protect the spacecraft and allow us to keep the proper temperatures so it doesn't get too hot or too cold. Really good question. There's another question from Milana. Is there a white hole? Not that I know of. Yeah, I don't know. I don't know that one. We'll have to keep our eyes out. And then Jen asked, do you think aliens are real? Well, I don't really know. But what I can say is that with these telescopes like Hubble and the other telescopes, we're seeing more and more stars and galaxies. There's billions and billions of stars in the universe. It's impossible to even imagine how many there are. So it's hard to believe that, it's hard for me to believe anyway, that somewhere on one of these stars, there's not another planet that there could be something living. But one of the things that I didn't get a chance to talk about much here, there are spacecraft that are specifically looking for planets going around other stars. And this Roman space telescope that I'm working on, one of the things that it's going to do, in addition to making the pictures that I show, it's looking for planets around the other stars. So we need a lot more information to figure that out. But I think it's very likely that there's some kind of life somewhere else. Okay, from Harim, when astronauts do a spacewalk, how long does it take them to repair the camera? So, the picture I showed with them repairing the camera, they were out about 8 hours. So that's a long time to be out in a spacesuit. It's actually pretty uncomfortable, but they were focused on their work. Obviously, it depends on what work that they're trying to do. But that particular time, that was a long spacewalk with 2 astronauts. They were out there, like I said, like 7 or 8 hours. And typically a spacewalk will be at least a couple hours because there's a lot of work that goes into just getting out, getting into your suit and getting out. So you want to make sure that when you go out in a spacewalk, that you can do a bunch of, do as much work as you can. All right. So Jamie asked, did you ever meet Sally Ride? Unfortunately, no. I am very inspired by Sally Ride, and she did some fantastic things as an astronaut and also as a person, but unfortunately, I didn't get a chance to meet her. So good question, though. And I would encourage you to read about her life. It's very interesting. How big is the biggest star we know of? I don't know the exact answer for that, but the largest stars, which are actually the cooler and red stars, are hundreds of times bigger than our sun. So the red ones tend to be big and cool. So maybe 100 times bigger than the sun, but I don't know the exact answer. You can probably look that one up. The next question from Ray was, do people age faster or slower in zero gravity? So a lot of things happen to the body in zero gravity. I can't say aging specifically, but basically muscles get weaker if you don't exercise, because a lot of the reasons that your muscles stay strong on Earth is the gravity that's forcing you on and your activity of walking around, running around, doing whatever you're doing. So basically kind of things that are like aging can happen a lot faster in zero gravity. Other things happen to your eyes and other things like that. So that's one of the things that they are working on in the space station, is to understand things like what I'm talking about, the effects on the body, and if there are things that we can do to minimize those effects. So that's a really, really good answer, or a really good question, excuse me, something we're still studying about. How long does it take to get to Mars? Shimon asks. So it takes about 9 months. So this Perseverance that's going to launch is going to launch in July, and it'll, well, it actually depends on when they actually launch, but it's going to launch in July, and it'll get to Mars something like January or February next year, depending on when they actually launch. Okay. Isabel, let's see. So yeah, I don't know, the picture that I showed for the new telescope versus Hubble, I don't know who took the surrounding picture. I think they were just trying to illustrate the comparison of the two telescopes. And then somebody asked, why is Crew Dragon called Crew Dragon? That's a great question. I don't know the answer. I know, so they came up with the name Dragon. That was a name come up with by SpaceX. SpaceX is the company that built the Falcon 9 and the Crew Dragon. They've been flying the Cargo Dragon to the space station for a while. So once they got Crew, they decided to call it the Crew Dragon. But I think Dragon is just a cool name, so that's why they did it. Let's see. So Emery asks, how big is the helicopter? Very good question. It's hard to show. So the helicopter is probably, if I reach my hands out, and you can't see my hands, but if I were to reach my hands all the way out, as far as I could go, that's about how big the rotors are on the helicopter. Okay, Aloria asks, why are there gas giants? Well, I'm not an astronomer, but basically planets, without getting into a whole science lesson, the planets in our solar system and other solar systems are basically made of material that was floating around, and over many, many, many hundreds of millions of years came slowly together and started rotating. That's how the sun started, and that's how all the planets started. So the gas giants, which a gas giant, if people don't know, that's a planet like Jupiter, Saturn, Uranus, and Neptune. Those are all gas giants. And those were made mostly out of gas that was floating around that condensed and eventually turned into a planet. Okay, let's see what else we got. So, pardon me if I pronounce your name wrong, I'll try. So, Manuka, do you want to go to space? So, absolutely, I do. But if I'm going to go to space, I want to go for a reason. I don't really want to go just for a joyride. I'd love to go to space and work on something. So we'll see if that happens, but I'm perfectly content to work here on the Earth and watch my spacecraft that I've worked on go up and do things that they're intended for. Let's see. So how long does it take to build a satellite? The shortest is maybe 3 years, and the longer can be more like 5 years. And I did not do anything or build anything on that Crew Dragon launch that just launched. I just wanted to show you that because I thought it was cool. Let's see. Then Isabel asked, do you have to keep the aircraft so clean, the spacecraft clean, because of the threat of malfunction or organisms? So most of the reason you're trying to keep it clean, if you think of a camera, right? If you ever use a camera or on your phone, if you take your finger that's got junk on it and you put that on the lens of the camera, what's going to happen? Your image is going to get blurred and it's going to get all messed up. And unlike, here on Earth, we can clean off a camera lens, but once a satellite's on Earth, or excuse me, out in space, we can't clean it. So we need to keep all the cameras very clean, and a lot of the other things like the solar panels and stuff like that, they need to be clean so that they will work properly. Most of the times, organisms like living things aren't a problem, but it's a really good question because the spacecraft that are going to Mars, so we don't want to contaminate Mars with our Earth organisms. So they do a lot of work cleaning and making sure that the spacecraft like Perseverance are basically sterilized so that we're not sending any organisms to Mars. We don't want to be, be bad about that. So for those kind of spacecrafts, organisms or biological stuff is important. Okay, so let's see what other questions we have. There's a lot of questions. So, so there was one about, do stars have orbits? So that's an interesting question. So there's a couple answers to that. First of all, there are what's called binary stars. So two stars that are close to each other and they can rotate around each other. So that's kind of like an orbit. And then almost all stars are orbiting or moving around inside their galaxy. So that's a really, really, really big orbit, and it takes a long time to go around it. But that's kind of my answer to that. Do stars have orbits? And there's actually stars where there's three. It's very rare, but there's three that are orbiting around each other. Let's see. Here's another, let's see, I want to make sure I get everybody, if there's anybody who hasn't asked a question. So there's one from Hannah Rayleigh. Great question. It says, would a spacecraft that would go to Mars need more than 3 stages? So they're still working on that. It could need more than 3 stages. The whole reason that you have a stage is most of what's inside a stage like that, first or second stage of the rocket, is fuel. So you burn the fuel, and then you don't want to be carrying that weight around. You want to get rid of that weight. So that's why you have a stage, so you can burn the fuel and then get rid of that weight. They are still working on what goes to Mars. Right now, spacecraft like Curiosity and Perseverance, they go on a rocket that has a big first stage with boosters and then a big second stage. But it really depends on how much stuff you're trying to bring. Okay, let's see. So Ilana asked, why are the spacecraft or the astronauts' helmets dark? Yeah, those are tinted because the sun is very, very bright in space. So just like we wear sunglasses, they want to have ways to protect their eyes so they don't get too much sun in their eyes and they can see. So that's an answer to that. There's a question from Jamie. How do you ship the satellites that you build here to send to space? Very good question. So like that Terra that I showed you, we put it in a special container. Basically, there's a part that holds the spacecraft, and then there's a big box that goes around it. And we actually pump clean air into that box so that it stays clean while it's going. That box gets put on a truck, a very special truck, and gets driven to an airport. In this case, I went with Terra when we took it to California. So we drove it down to Delaware in the middle of the night. We put it on a gigantic airplane called a C-5, which is basically one of the biggest aircraft that are flying. The truck actually drives into, the whole truck drives into the airplane. They tie it down, and then those of us that were going in it, we went up and went in our little area where we could sit in the airplane, and we flew it. So generally it's by airplane. Really small ones you can do by truck, but usually it's airplane. So let's see, what else? There's a good question here. Has NASA tried to send rovers to Mercury or Venus? That's a great question. So we didn't talk about the planets too much. That'll be for another time. But so let's talk about what those planets are like. So Mercury is close to the sun. If you look at it, it's kind of like the moon. It's really dead. There's no atmosphere, and it's very, very harsh environment. So there was actually a spacecraft that some friends of mine worked on that went and orbited around, that actually is still orbiting around Mercury, but we have not tried to send rovers there, basically because we think that there's some other places like Mars and some Saturn, some other places that are really more interesting. Then Venus is a totally different story. Venus has really thick clouds, and it's very, very hot. And the clouds have acid, so when it rains acid. So it's a very, very, not very nice environment on Venus. People think of Venus as, you know, a peaceful, mythical planet, but actually it's a really, really hard place to be. There have been spacecraft that have landed on Venus. Actually, the Soviet Union sent a couple spacecraft that landed, but they only lasted like an hour because basically the environment was so harsh that they were there for a few minutes and then they just failed. We have sent spacecraft to, again, go around both of those planets, and I think there's some people that want to go back to Venus, but we haven't done any rovers there. Okay, let's see what else we got. Let's see, and you can help me out, Liz.
There's one from Emory about does Starlink
Oh,
make your job harder?
no, Starlink doesn't make my job harder. Thanks for the question.
Is
So,
Starlink?
yeah, so Starlink is basically a set of communication satellites that SpaceX is putting up. And I think maybe what Anne-Marie is talking about is there's many, many, many of these little satellites. So what you have to do is you have to make sure that you don't send another spacecraft into an orbit that can run into one of those, to any satellite, and particularly the Starlink ones. So my personal job, it doesn't make it harder, but the people that are figuring out where they're going to shoot the rocket, what its trajectory it's going to be, the more and more spacecraft that are up there, the harder it is to do that, to make sure that we don't run into anything. There's a lot of things in space around the Earth now, and there's a lot of work that's being done to try to control the amount of stuff, trash, or satellites in orbit. And there's a lot of people working on if there's ways that we can clean up some of that trash. They haven't really done that yet. There's a lot of people working on that. Okay, what else do we have? One is, what happens to tears in space? Well, so in space, you know, on the space station, or if you're not on the moon or a planet, there's no gravity. So tears or any other liquid will just float around until it hits something. So yeah, I guess if you cried a lot, then those tears would be floating around. And then the other part of the question was, has NASA put spacesuits on animals before? The answer is yes. In the very early days, before they had figured out how to send people into space, they actually sent animals. They tried to take as good care of the animals as they could, but they did put spacesuits on them, and they launched them and brought them back safely. So we're not doing that anymore. That was back, you know, around the time I was born in early 1960s, but yes, they have. And there was actually a dog also on a couple of missions that the Soviet Union did. Okay, see some other ones. Do people meditate in space? Well, you know, when you're off duty in space on the space station, you can kind of do whatever you want. It's very important to rest and rest your mind. So I'm sure, yes, people most likely do meditate in space and do whatever they need to do to rest and recharge, just like all of us have to do. Let's see. There's another question that says, why do we orbit the sun? So we orbit the sun because the Earth is moving pretty fast. And as I mentioned, when the solar system was first formed, it was basically formed by material coming together and starting to spin around. So when all that happened, and that was 4 or 5 billion years ago, a long time ago, all that motion got started. If the stuff wasn't spinning around, then it would have just all ended up in the sun and just became one big star. But the way solar systems form is basically pockets of material, local areas of material condense and form planets or asteroids or all that kind of stuff. I am not an astronomy expert, so you could probably go on the internet and find a better explanation of that. But anything that's orbiting, like a spacecraft, has some energy, basically has some speed. And when we launch something into space, we're basically giving it a whole lot of energy so that it can spin around and go into orbit. That's the way that works. All right, so let's see what else. These are really, really good questions, and thank you very much. And we've been an hour, so I'm happy to keep going. If there are other questions, I don't mind continuing to try to answer, but this is really fun. So one person said, can you go through a star? That was Aloria. I don't think so. I think it would be very hard to go through a star. I know we have all these science fiction movies like Star Wars and stuff that I love to watch, but like if you want to go into hyperspace and go through a star, I don't know what would happen. So generally you want to kind of stay far enough away that you don't get into trouble. Let's see what else. And obviously, if a star exploded, is it dangerous? Yes, it would be very dangerous. If our sun exploded, it would, that would be very, very bad. But the sun is not going to explode, at least not for many, many, many years. So that's not something that we have to worry about. But you saw those pictures that I showed of the nebula. Again, those are all what happens to certain stars when they get to their end of their lives and they blow up. All right, let's see if there's any other ones. If you have any other questions, feel free to write them in the chat window. And yeah, we've never been anywhere near, the nearest star to our solar system is about 6 light years away. So that's way, way far, basically way, way further than we can travel right now. So there's never been a spaceship near a star that's exploded. So I'm interested what all of you guys and you ladies come up with. Maybe you'll come up with some new way of moving us around. One of the big things that people are working on is propulsion. Basically, how do we make a faster rocket, a faster vehicle that can get us places faster than what we can do now? We've kind of gone as far as we can with the current technology. So now we got to get some really good ideas and figure out some different ways to do that. Aloria asked, how old is the sun? I think the sun is about 4.5 billion years old. That was basically the start of the solar system. And we don't know it for a fact, but most likely there was a star before our solar system that blew up, and then eventually the material, some of that material came back together and formed our solar system. And let's see, another good one is, what's the estimated time an astronaut must train? Very good question. They train for a long time, probably at least 3 or 4 years, and most likely even more. I do have a couple friends that are astronauts, and they had to do a lot of training before they were able to fly. Okay. And I guess we'll take, there's another question. Did the planets form one by one or all together? So they formed one by one, but all in the same area, rotating around the sun. And again, that's back a long time ago, 4.5 billion years. All righty.
Wow.
So I hope this was fun for everybody. I hope it was interesting. There's so much to learn about space, so I hope you will feel free to look on the internet. I'm actually,
That sure was.
yeah, so thanks everybody for joining. Really appreciate it, and have a great night. Thanks again.
Thank you, Mark. Fantastic.
Okay.
Thank you.
Thank you.
Thank you.
Thank you so much.
Thank you.
Thank you.
You.
Thanks so much. Thank you. Thanks. Yeah. Thank you.